Hello Year 6 and welcome to today's science lesson. This is our second lesson on light and today we're going to be learning how does light travel to our eyes. All right, before we get started with the lesson, let's do a review quiz. So please get your pen and paper out and write down your answers. Question 1, true or false? Ultraviolet rays are short rays that travel from the sun to the earth and can be damaging to our skin. Please pause this video now and write down true or false. Question 2. Which of these cannot be used to protect us from the sun? A. Sunglasses. B. Sun cream. C. A hat. Or D. Moisturizer. Please pause this video now and write down your answer. Question 3, delete as appropriate. As we get younger or older, our eyesight usually broadens or deteriorates. So choose the correct one from each of the ones inside the bracket. Pause this video now and write down your answer. Question 4. What charge do electrons have, positive or negative? Pause this video now and write down your answer. And a question from last year, what temperature does water freeze at? Okay, let's go through the answers. So question 1 is true. Ultraviolet rays, also known as UV rays, are short rays that travel from the sun to the earth and can be damaging to our skin. Question 2, which of these cannot be used to protect us from the sun? All of these things can be used to protect you from the sun except for moisturizer. You can put on moisturizer or aloe vera after you get sunburnt, but it's not going to protect you from getting burnt. As we get older, our eyesight usually deteriorates. Deteriorates means gets worse. And electrons have negative charge. Remember, electrons flow through an electrical circuit. And water freezes at 0 degrees Celsius. That's why when it's below 0, it snows. And the snow only stays settled when it is below 0. If it's above 0, the snow will melt. Okay, vocabulary. Let's review some vocabulary from last week. Ultraviolet rays, also known as UV rays, are these short rays that go from the sun to the earth. And some of them get trapped by the ozone layer, but some do get through. That's why we were talking about the ozone layer last week and the fact that there used to be a larger hole in the ozone layer, which meant that more UV rays could come through. But because we're using less CDC gases, now the hole in the ozone layer has shrunken, which means that less UV rays come through, which is good. Opaque. Opaque is when a material is not transparent. So a really thick cardboard-like material is opaque, and that's why we did those experiments last week by pointing light or torch through materials to measure how opaque or transparent they were. And if the light shone through a material, it was transparent and it was therefore not opaque. Reflected. So light can reflect off a mirror, but as we will learn, light can also reflect off other objects. So when something is reflected, it bounces off something else. All right, new vocabulary. So pupil. This black circle here is a pupil. You can look in the mirror and spot your own pupil and look at how big it is. Constricted. When something is constricted, it becomes smaller. So last term, we learned about your windpipe sometimes constricting, and that is when something gets smaller. So which of these pupils do you think is constricted? Take a moment to think. Yes, it's the one on the left. This pupil is constricted because it is smaller. Dilated. When something is dilated, It's a circle that becomes bigger and wider. So which of these pupils is dilated? Take a moment to think. It's the pupil on the right. This pupil is dilated because the circle is wider. Iris. The iris is the colourful part of your eye. So all of you will have a different eye colour. Everyone in the world has a slightly different eye colour. And this is called the iris. So how does light travel? Step 1, light travels in straight lines from a light source. So a light source can be anything from a lamp to the sun to a torch to a phone. Last week we looked at different types of light sources. Here we have the sun being a light source, and it travels in a straight line from the sun to this box. And here the light source is what? It's a torch, and it's traveling straight from the torch to the apple. That is step 1. Question for you. Does light travel in a wavy, curly, round line, or does it travel in a straight line? Yes, light travels in a straight line. Step 2, light is reflected. So we spoke about what reflected means, and you might think of a reflection happening most commonly when you look in the mirror. Light is reflected in a mirror. That's absolutely true. But light can also be reflected off other objects. So here we see light going in a straight line from the torch, the light source, to the mirror, and it then bouncing off, being reflected. Once the light hits the apple, it is reflected off in the opposite direction. That is step 2. And step 3 is light from the apple is reflected into the eye. So it bounces off the object and it's reflected into the person's eye here. And that are the 3 steps of how light travels from the light source to the object, bounces off, is reflected, and goes back into your eye. Now, let's look at these 3 diagrams. Why are they wrong? Which direction should the arrows be pointing? What's wrong with diagram 1? Take a moment to think about it. Well, these arrows are pointing in the wrong direction. The arrows should be going away from the light source to the dog, and then it was reflected off the dog back to the eye. So these arrows should be pointing the exact opposite directions. Take a look at this diagram in number 2. What's wrong with the diagram in number 2? Pause this video now and have a think. Well, we can see this first arrow pointing from the light source to the dog. Is that correct? Yes, that arrow is correct. However, this arrow is pointing from the eye to the dog. It should be pointing the other way around because the light is reflected off the object back to the eye. And please take a look at diagram number 3. What's wrong with this diagram? Well, we see here that the light source is the candle, and so therefore it's correct that the light is going away from the light source to the object. However, there should then be an arrow going from the object to the person. There's never light going from a person to the light source because a person's eye is not a light source. So this is what the correct diagram should look like. We have the light source, light traveling in a straight line from the light source to the object, it being reflected off the object and going back into the eye. So what I would like you to do is please draw this diagram and annotate it in your book. So let's start off by writing today's date, which is Monday, the 1st of March, and writing today's title, which is How Does Light Travel to Our Eyes? That is today's question. Now, first thing we need to draw is a light source. Now I'm going to draw a lamp here, but you can draw the sun, you can draw another type of light, you can draw a light bulb, or you can draw a candle. As long as it is a light source, it can be both natural and man-made. The next thing that you should draw is the object. Now I'm going to draw an apple. However, you can draw any object you want. You can draw a dog, a box, or anything that you see. And the third thing that you need to draw is either an eye or a person with an eye or a face with an eye. So I'm just going to draw an eye there. There's the iris and the pupil and the eyelashes. And then I'm going to get my ruler and draw the important two arrows. There's the first arrow, step 1, of the light going in a straight line from the light source to the object. And there's my second arrow of the light traveling from the object to the eye. And then I'm going to annotate my diagram. That's the light source. This is the object. And that is the eye. Okay, so the next thing that I'm going to do is write step 1 out. Light travels in straight lines. Oopsies, jumped a bit too far. Here are the 3 steps. Light travels in straight lines from the light source to the object. Light source to object. Step number 2. Light is reflected off the object. It bounces off the object. And step number 3, light travels from the object to the eye. So you have to, at every stage, say where light is coming from, where it's going to, light source to object, and object to eye. And if you can say that light travels in straight line somewhere, that would be very helpful. And remember at stage 2 to say light is reflected off the object. Okay, now pause this video now and please draw your beautifully annotated diagram. Okay, here's a question for you. Do you need to see the light source in order to see? Well, think about, why can we see the moon in the sky at night, even though at night time there's no sun because it's night time? So this tells us that we do not need to see the light source in order to see. All that is important is that light is reflected off the object in order for us to see. So here we see the beautiful moon in the sky, and even though there's no sun in sight, we can see the moon because light is being reflected off the moon from a light source, the sun, and bouncing back into our eyes. Now let's look at it in this diagram. Where's the light source? Can you point to it? The sun is traveling in a straight line to the earth, and it's being reflected onto the moon. And that light then bounces back into our eyes and we see it from Earth. So here's a question for you. Is the moon a light source? The answer is no. The moon is not a light source. It's not producing light. The sun is a light source. The moon merely reflects the sunlight back. Okay, what happens when light reaches the eye? What do you notice about these 2 pupils? Pause for a moment and think about it. Well, we can see that this pupil, the pupil, remember, is the black hole, is a lot bigger in this picture than in this one. I wonder why that might be. Well, what is a pupil, first of all? The pupil is the black hole, and the iris is the colourful part. So sometimes it's brown, sometimes it's blue, sometimes it's green, sometimes it's grey. What is a constricted pupil? Well, a constricted pupil is a smaller pupil, and a dilated pupil is a larger pupil, like we see here. What do you notice about these 2 sets of pupils in this monkey? Well, you'll probably notice that the pupils in this monkey are smaller, they're constricted, and they are dilated in this monkey here. Next question, what do you notice about the conditions that these monkeys are in? conditions. Look around the monkeys. What do you notice? Well, you might notice that it's nighttime, it's dark around this monkey, and it's daytime here. So what can you infer from that? How is the darkness or brightness of its surroundings related to the size of its pupils? Well, we can infer from that in darkness, your pupils are bigger, and that in a brightly lit place, your pupils are smaller. That's because this is a hole. So in darkness, the hole gets bigger, so more light can be let in. In brightness, the hole gets smaller because less light needs to go in. It's to protect the eye. So, which is a constricted pupil? Can you point to it? It's this one on the right, which is in a more brightly lit place. And which pupil is dilated? It's this one, which is in a darker place. Okay, how can we test this? Well, we're going to do an experiment where we're going to look at our own pupils. Step one of this experiment is you have to turn off, just watch me do it before you do it, and I'm going to model it. You have to turn off all of the lights in the room that you are in. So you can either do it in a bathroom or any room where you can turn off as many lights as possible. Right, turning off all the lights in this room. So it's really dark. There's still a bit of brightness because of this computer, but when you do it, you can do it in a completely dark room. Now, let me take off my shared screen. So, what you would do is look into a mirror. So that's why I say you can do it in the bathroom, because there's usually a mirror there, or you can find yourself a mirror. And what you need to do is wait for about a minute to let your pupils adjust to the darkness. So what's happening now is your pupils are going to be getting much bigger because it's dark. And then what I need you to do is look in the mirror, come really close to the mirror and look at the size of your pupils. Just stare at your own eyeball and look at the size of your pupils, and you'll notice that they're getting bigger and bigger. So that little black hole is getting bigger. And then what you need to do is be near a light switch that you can turn on, or get your brother or sister or whoever you're with to turn on the light. But you have to make sure that you are staring at your pupil when that light goes on. And you have to really do it in that moment. You'll notice that your pupil will suddenly get smaller. Your pupil will suddenly move from a dilated state to a constricted state. So let me just repeat the instructions. You need to go into a room, turn all the lights off, sit or stand in front of a mirror, look at your pupil, and then turn a light on and see whether your pupil suddenly gets smaller. And you can do it as many times as you want. And let me know what your results are. Okay? So there's the experiment. I'm going to go back to sharing my screen. There we go. And we are then going to write up our results of this experiment. So I investigated. You're going to first say what you investigated. So you're going to write, I investigated the impact of light on the size of my pupils. So you could say I investigated the impact of light on the size of my pupils. The next thing that you need to write about is what you noticed. I noticed that when the light was off, or when it was dark, that my pupil was larger. Or if you want to use a scientific term, you could say it was dilated. And when the room became lighter, the size of my pupils became smaller, or you can say constricted. So after writing a sentence explaining that, I would like you to please draw 2 diagrams of your eyes, and you can guess. You need to draw one with your pupil dilated and one with your pupil constricted. So, which of these 2 is in the dark room and in the light room? Well, the pupil on the left is in the dark room because it's dilated, and the pupil on the right is in a bright room because it's constricted. And then what I need you to do is annotate and label these 2 diagrams. So you're going to need to firstly annotate the pupils, say which one's larger and which one's smaller, but you also need to use scientific terms. So you can't just say bigger and smaller, you have to use the scientific terms that we taught you. So a larger pupil is the pupil is dilated, and for the bright room, the pupil was constricted. So I hope you enjoyed this experiment, Year 6. I can't wait to see your beautiful diagrams on Seesaw. You can also let me know how you found the experiment and whether you saw a big change. Bye, Year 6.